The paper of the day is Harvest, Yield, and Scalable Tolerant Systems. The cost of reconciling consistency and state management with high availability is highly magnified by the unprecedented scale and robustness requirements of today's internet applications. We propose two strategies for improving overall availability using simple mechanisms that scale over large applications whose output behavior tolerates graceful degradation. We characterize this degradation in terms of harvest and yield and map it directly onto engineering mechanisms that enhance availability by improving fault isolation and in some cases also simplify programming. By collecting examples of related techniques in the literature and illustrating the surprising range of applications that can benefit from these approaches, we hope to motivate a broader research program in this area. CAP, CA without P. Databases that provide distributed transaction semantics can only do so in the absence of a network partition separating server peers. CP without A. In the event of a partition, further transactions to an ACID database may be blocked until the partition heals to avoid the risk of introducing merge conflicts and thus inconsistency. AP without C. HTTP web caching provides client-server partition resilience by replicating documents, but a client-server partition prevents verification of the freshness of an expired replica. In general, any distributed database problem can be solved with either expiration-based caching to get AP or replicas and majority voting to get PC, the minority is unavailable. Let's look at definitions of harvest and yield. We assume that clients make queries to servers, in which case there are at least two metrics for correct behavior: yield, which is the probability of completing a request, and harvest, which measures the fraction of the data reflected in the response, that is the completeness of the answer to the query. Yield is the common metric and is typically measured in nines. 4 nines of availability, which means a completion probability of 0.9999. Looking at the contributions of the paper, specific mechanisms that they have been able to exploit to simplify engineering and improve robustness of our scalability includes following 4 items. 1. Simple mechanisms with small state spaces whose behaviors are easy to reason about, for example, timeout-based partial failure handling, guard timers, orthogonal security, etc., inspired by orthogonal mechanisms in the safety critical systems. Second, the orthogonalization of these mechanisms with respect to application logic, separating the application functionality from the provision of high availability. The composition of SNS and SRM provide a good illustration of this approach. The replacement of hard state with refreshable soft state, which often has the beneficial side effect of making the recovery code the same as the mainline code. The load balancing manager in SNS works this way, using refreshable soft state mechanisms inspired by the IP multiclass routing and SRM state pair. Overall tractability of large-scale engineering involving hardware replication and redundancy. Only a very few expensive specialized systems such as Teradata's 768 node data mining cluster really compare in size and aggregate capacity to cluster-based internet services.